Hello everyone, this is Cal. Today we are going to learn one of the fundamental factor multiplications, the basis for understanding geometry and physics. Previously, we've learned about the dot product, also known as the scalar product. The dot product is a way to multiply two factors by measuring how much they point in the same direction. So, if we have two factors, factor u and factor v, calculating their dot product means finding the magnitude of how much they align. To compute that, we use trigonometric relationship as shown here. Since each component of a vector has unit vectors I, j, and k, any perpendicular components form a 90-degree angle, which makes their dot product equal to 0. Therefore, the dot product between vectors u and v can be written as follows. This time, we're going to learn how to multiply two vectors in three-dimensional space to produce a new vector that is perpendicular to both. So, if we have two vectors, u and v, their cross product will result in a new vector. Let's call it k, which is perpendicular to both u and v. But we need to remember that the vector perpendicular to both u and v is not unique. There are two possible directions as shown in the figure. Today, we will examine this possible direction of the cross product result and understand when to use each one. Okay, let's assume the cross product of vector u and v is vector k. If vector u is perpendicular to k and vector v is also perpendicular to k, then both dot products u dot k and v dot k are equal to 0. Therefore, we obtain the following two equations. Now, we will solve these two equations to find the expression for each component of vector k. First, we will eliminate the z component of the coordinate to simplify the equation. To make this equation valid, there are two possible conditions we can use, and both are correct. The first condition states that minus yk equals to xu zv minus zu xv and xk equals to yu zv minus zu yv. While the second condition states that yk equals to xu zv minus zu xv and minus xk equals to yu zv minus zu yv. Okay, now let's first examine condition 1 and substitute it into the perpendicular equations of u and k. After solving for the z component of k, we substitute it back into vector k. This allows us to write the expression of the cross product between u and v as follows. Next, let's also try using condition 2. We'll again solve for the z component of vector k and substitute it back. Then we can see that the result of the cross product between vector u and v looks like this. Now, we can observe that the result from condition 1 and condition 2 are different. We can assume that under condition 1, the resulting vector points upward. This means that under condition 2, the resulting vector points the opposite direction, in this case, downward. So the question is, which direction should we take as the standard? Based on several physics experiments, such as magnetic force, torque, and angular momentum, we can see that the resulting force is always perpendicular to the direction of the vector involved. From these experiments, it is concluded that condition 1 is used as the standard, following the convention that occurs naturally here on Earth. Therefore, if we have two vectors u and v, the cross product between them is written as follows. Next, let's find the magnitude of the vector resulting from the cross product of u and v. We can use the formula for the magnitude of a vector, which gives us the following expression. Then we'll square the magnitude of the cross product and simplify it to obtain a compact formula. Since the dot product can also be written as follows, its square form can also be expressed this way. We'll also calculate the product of the magnitudes of u and v and find its square form. Now, let's combine the three equations we obtained. Using a bit of basic algebra, we can rearrange the equations like this and compare them with the other two. Here, the first part matches the squared product of the magnitudes of u and v, while the second part matches the square form of their dot product. Since we already know the formula for the dot product, we can substitute it here. After rearranging, we'll see that the equation contains the term 1 minus cos squared theta. Using the trigonometric identity, 1 minus cos squared theta equals to sine squared theta. We can rewrite the equation as follows. Therefore, the magnitude of the factor resulting from the cross product of u and v is given by this formula. In conclusion, if we're asked for the magnitude of the factor resulting from the cross product of u and v, we can use the following equations. Since the magnitude of a factor can also be expressed using its unit factor, the full form of the cross product between u and v can be written as the following equation, where mu is the unit factor perpendicular to both u and v. Okay, that's all for today. I hope what we've learned today will be useful in your learning journey. See you next time. Bye.